Dr. K.S. Ramakrishnan is working as an assistant professor, School of Education, Tamil Nadu Open University, Chennai 15. He has been teaching science education, environmental science, educational technology and research methodology in various colleges of education and Tamil Nadu Open University for the past 9 years. He has guided so many M.Ed, M.Phil and PhD students. His current research areas are environmental education, educational technology and media and communication. He has conducted various workshops on ICT usage in education, Wiki Educator, e-content development and educational research methodology. He had attended many online workshops on Moodle, learning analytics. He has published 6 books and many articles in national and international journals of repute. He regularly gives plenary and keynote speeches on environment and ICT related issues at various national and international conferences. He has delivered 28 episodes of the program Pudiyodor Ulagam at All India Radio, Chennai, related to various new developments in science and technology.
Welcome to UGC CEC program on environmental science. In this episode, we are going to discuss about the mode and median. These are the two basic quantities in statistical analysis, and we are going to discuss about the meaning of measures of central tendency. What is central tendency? The calculation and interpretation of mode and median, the situations where mode and median are used, the advantages and disadvantages of mode and median. So, these are all the 4 aspects that we are going to discuss today. Now, let us see what is the central tendency. The central tendency, let us take an example. Suppose there are some data, and in case if most of the values cluster around a central figure, for example 16, that means it represents the whole group. That means all the data that can be represented by that value 16, and that is called the measure of central tendency. And the items with values less than that, they cancel the item values greater than that. So, that means that that particular value, the values lesser and the values greater, all are equally distributed, and therefore, that is a central value, and that is called the central tendency. And we are going to discuss about the mode, median and mean. So, these are all the common central tendency that we are discussing in statistical analysis. And now, let us discuss about the mode. The mode is the most common item of a series, and it is defined as the value which occurs the largest number of times. That means, in a series, if any value is occurring the largest number of times, that is called the mode. Or we can say the value around which the greatest concentration of value occurs. That means, if some number that is occurring the largest number of times, naturally that is concentrated with many values. Or when 2 scores occur the same greatest frequency, the data set is bimodal. So, it is not necessary that a data set is having only one mode. In case if 2 values are occurring the same greatest number of frequencies, that is called bimodal. And similarly, if more than 2 scores occur the same greatest frequency, each is a mode and the data set is multimodal. You look at the data, and here the value is 4, that is occurring 1, 2 and 3. And similarly, the value 5, that is also occurring 1, 2 and 3. And therefore, 2 values are occurring the greatest frequency, and therefore, it is a multimodal with 4 and 5 as the modes. And now, suppose if the data set is singular, we can say, or we can easily find out what is the mode. Suppose if the data set, that is a grouped data, and there is a class interval and the frequency, and it is starting from 0 to 10, 10 to 20 and all, and therefore, the class interval that is 10, and here the class interval 20 to 30, it is having some 9 items. That means, the frequency is 9, and therefore, definitely the same definition is applicable here, and which value is occurring the largest number of times, that is called the mode, and therefore, this class interval is consisting of the mode, and therefore, the midpoint of the class interval, that is 25, is taken as the mode. So, in that way we can calculate the mode of a grouped data. And look at this example. Here the class interval 20 to 30, that has the frequency 14, and 40 to 50, that is also having the frequency 14, and therefore, two class intervals are having the highest number of frequency, and again it is a bimodal, and 25 and 45, they are called the modes. And now let us see what is the formula for calculating the mode. And look at the formula, and here the mode is equal to L suffix MO plus D1 by D1 plus D2 into W. And here L suffix MO, that is the lower limit of the modal class. So, what is the lower limit? As we have seen, if this is a modal class, the 20, that is the lower limit, and D1 is the frequency of the class succeeding the modal class, and therefore, if one modal class is there and the frequency of the class which is succeeding next the modal class, and similarly D2, that is the frequency of the class preceding the modal class, and W is the width of the modal class. And therefore, by using this simple formula, that we can easily calculate the mode. Now, let us take an example. You look at this class interval, and here without any doubt we can say the class interval 100 to 150, that is the modal class, because the highest number of frequency. But now, how to calculate exactly what is the frequency? And therefore, we have to apply the formula, and here the class interval, that is 50, and the frequency of the class preceding the modal class, that is 123, and succeeding the modal class, that is 82, and the class interval, the lowest class interval, that is 100, and therefore, now let us apply into the formula, and here the modal class, that is 100, and D1 is 82, D2 123, W 50, and if you are applying into the formula, we are getting 120, and therefore, we are exactly correct, because this 100, we can say that 100 to 150, the mode is there, but exactly what is that? For that we have applied the formula, and we have calculated 120 is the mode, and therefore, we can find the mode by using this simple formula. And now, what are the uses of mode? Where it is used? See, when the most frequently occurring value or the most typical value is wanted, suppose we are having a data set, we want to know what is the most occurring frequency. For example, the most preferred leader, the frequently occurring mark. For example, in a class test, one particular mark that is occurring so many times. For example, you take 70, and therefore, the 70 mark is occurring many times. That means, many students could have got the mark 70. And if you are particular in identifying that mark, then we have to go for the mode. And similarly, which leader he has got the more number of votes, and for that we can use the mode. And when a quick and approximate measure of the central tendency is needed, as we have discussed, the modal class or where the mode is situated, that can be immediately found out by looking at the data, and therefore, in that situation we can use the mode. And when the data is skewed or incomplete, for example, for very skewed data, it is difficult to calculate the mean or some other central tendency. And so, in that situation, we can use the mode, which is somewhat relatively easy to find out the mode. And what are the advantages? It is not affected by extreme value. See, for example, in a data set, the extreme value, this one or that one. And in case if you are changing the extreme value, the mode will not change, and we can use it even when one or more of the classes are open ended. And so, these are all the situation where the mode is exactly useful. And now what are the disadvantages? It is a rough estimate and it cannot be subjected to further statistical analysis like mean, standard deviation. They can be further analyzed, but the mode cannot be analyzed further. And it is ill defined, indefinite and not the ideal average. See, as we have already discussed, a single data set can have many number of modes, and therefore, which mode that you will take as a central average or the central tendency, and there is no definition of that. In many cases, it may not be possible to get a definite value of mode. We can't say which is the exact mode. There may be 2 or 3 or more modal values, and mode is not based on all the observations of a series, and it simply says which value is occurring many times, and that data set may contain 20 data or 30 number of items. It is immaterial, and which value is occurring the largest number of times, and it depends upon the selection of the class interval. So, all these are the disadvantages of the mode. Now, let us discuss about, in case if a graph is given, then also we can find the mode. You look at the graph, this is a frequency polygon, and we may notice that the values 1 and 4, they are occurring the maximum number of times, and all other values are in between. And therefore, we can say by looking at the graph, we can say that the values 1 and the value 4, they are the modes of the data set, and therefore, this is another way to find out the mode. Now, the second central tendency, that is the median. It is the value of the middle item of a series arranged in ascending or descending order of magnitude. It divides the series in 2 equal parts, one part containing values less than median and the other part containing values more than the median. That means, the data set that you are arranging in ascending or descending order and the middle value, that is called the median, and therefore, the median is dividing the data set or the value into 2 parts, and so on the left hand side the value is lesser and on the right hand side the value is more, and therefore, exactly that it is dividing the data set into 2 equal parts, and therefore, it is called the median. And similarly, in road also that we talk about the median. What is the central median in a road? And that is dividing the road into 2 equal parts, and therefore, that is called the median. Now, let us have a break. Welcome back. Let us proceed. We have been discussing about the median. It does not take into account values of all the items in a series, and by keeping the mid value constant, if we change other values, the median will not change. See, it is a mid value, and therefore, suppose the left hand side value is some value that you are changing, or the right hand side, and then also still it is a median, and therefore, the extreme values are not affecting the median, and therefore, it is called the positional average, and therefore, it is only a position. It is not telling exactly what is the average value, but then also it is dividing the data set into 2 sets, and therefore, still it is useful. And now, let us calculate how to find out the median of a ungrouped data. Suppose a data set is given, it involves 2 basic steps. We have to find out the location of the middle item and finding out the value. And the middle item in a series of individual item is n plus 1 by 2th item, where n is the total number of observation. That means, the n plus 1 by 2th item that we have to find out, and as we have already discussed, and let us take an example. In this data set, there are 9 items are there, and we have to arrange them in ascending order, and here the n plus 1th item, that means 1, 2, here 9 plus 1 by 2th item, that means 9 plus 1, 10, 10 by 2, that is 5. So, the 5th item, that is the median, and therefore, the 5th item, that is 9, and therefore, as far as this data set is concerned, 9 is the median. Now, another example, and here the number of items, that is even, and the same way that we have arranged the data into ascending order, and the same formula n plus 1 by 2th item, that is 8 plus 1 by 2, that is 4.5. So, in that case, how to find out the median? So, the 4.5th item, that is equal to the 4th item plus 5th item by 2. That means, the 4th item is 15, 5th item is 17 by 2, that is equal to 32 by 2, that is equal to 16. And so, by this formula that we can find out the median. So, in these two cases, the data set, that is somewhat simple, ungrouped. And in case if it is a grouped data, how can we find the median? So, in this example, the daily wages and the number of workers and the data set that is given, and here the daily wages, that is 5, 7, 8, 10, something like that, and the number of persons, and we are calculating the cumulative frequency. That means, the cumulative frequency of one particular interval, that is all the frequency before that, and that means the cumulative frequency of this interval or this particular frequency, that is 15 plus 20, that is 35, and 35 plus 12, that is 47. So, in that way that we can calculate the cumulative frequency. And now, what is the formula? It is always n plus 1 by 2th item, and therefore, the model class which is having the highest frequency, that is 18, and therefore, the model class, that is 80, and therefore, now the n, that is 80, and therefore, the median, that is n plus 1 by 2, and that is 40.5th item, and therefore, 40.5th item, where it is falling? It is falling somewhere in this item, and therefore, now we can say that the median value, that is 8, because the 47 and that is having the daily wages equal to 8, and therefore, in this example the median, that is 8. So, what is the physical meaning of that median? It is exactly dividing the frequency or the data into two equal parts, and below and above, and therefore, exactly it is standing in the middle, and therefore, that is the meaning of that median. And now, how shall we calculate the median in a classed interval? There is a small formula, m is equal to L plus n by 2 minus Cf by f into I, where L is the lower limit of the median class, n by 2 the middle number, Cf the cumulative frequency of the class preceding the median class, f is the frequency of the median class, and I is the magnitude of the class interval. And now, let us have an example how to calculate the median, and let us take this data set, the age, the frequency and the cumulative frequency. And now, let us fit these values into the formula. The median is the value of n by 2th item, and here the n, that is 140, and therefore, 140 by 2th item, that is the 70th item, and it is lying in the interval 30 to 40. So, 70th item means it is somewhere in this, and therefore, it is in this class interval 30 to 40. Now, L, that is 30, and n by 2, that is 140 by 2, that is equal to 70, and the cumulative frequency, that is 42, f is 32, and I, that is the class interval, that is equal to 5. And now let us fit all these values into the formula. The median, that is equal to L plus n by 2 minus Cf by f into I, and by putting all the values that we are getting, it is equal to 34.20. As we have already discussed, the median, that is lying in the interval 30 to 35, and therefore exactly 34.20, that is lying in between 30 to 35, and therefore as we have already seen, it is the median class. And therefore, my dear friends, that by using this formula we can find out the median for some grouped data. And now let us discuss what are the uses of median. And when we want to know the position of either lower half or upper half, that means if we want to know the position, which is central value that is dividing the data set into two equal parts, lower and upper, then we can go for the median. And where half of the class stands out, not the mean value of the class, here we are not calculating the mean. The mean value is something else which is exactly dividing the data into two, but here the data set, it is the middle value. That means that exactly the number of items standing on the left hand side, on the right hand side, that means below and above, they are equal, and therefore it is dividing the data set into half, that is all. And when the distribution is incomplete, still we can use the median. And now what are the other uses? When the distribution is extremely skewed, the median is taken into consideration than the average, or some cases when the point dividing the sample into two is needed, and so in all these cases that we can use the median. And now what are the advantages of median? It can be easily calculated and understood without any difficulty, and it is not affected by the extreme values. Even if the extreme items are not known, median can be calculated if the number of items is known. That means, if we know exactly what is the number of item, then we can calculate the median. And where ranking or order is used, it gives the average easily. So, these are all some advantages of the median. And what are the disadvantages? It is not suitable for further treatment, as in the case of mode, we cannot use it for further analysis. If big or small items are to receive greater importance, median would be an unsuitable average. The assumption that all the frequencies of the class intervals are uniformly distributed may not be true in many cases. The arrangement of items in ascending order is sometimes tedious, because if the number of items are less, some 5, 10, something like that, we can easily arrange. But if the number of items is large, then it is very difficult to arrange them in the order, and therefore it is somewhat tedious. Now, let us summarize. In this episode, we have dealt with the definition of central tendency, mode and median, and we have dealt with the calculation of mode and median, and we had also discussed the uses, advantages and disadvantages of median and mode. Now, let us have some questions. Define mode and median. And second question, when a series is called multimodal. And the third question, when the data is skewed or incomplete, which is useful, mean or mode? The fourth question, why median is called the positional average? The fifth one, median is not affected by the extreme values. Justify this statement. And the last question, mention two situations where we cannot use median. So, with that we are concluding this session. Thank you.